Welcome all of you back to campus. I'm sure most of you had a wonderful time over the vacation. Welcome back. But before I begin, did you have an idea you'll be taking up this course this semester? To campus again. I've started recording of this. I hope to put it online for you guys to also watch, so that at least those that will miss the class today will have the chance to also see what's going on. With that said, if you vanish now, I know you're about 53 in here. If I realize most of you are running, I will not load this video. I'm not going to load it on the platform for you to see. I only put up the slides for you to see. All right, so you already know who I am. I'm Felix Labiaye. I'm the one to take you Internet of Things with the course code of IS273. Now, at the end of the lecture, these are, well, let me begin by, first of all, telling you the course objective for this particular lecture, the course itself. Now, the objective of this course, which is Internet of Things, is to explore the Internet of Things as the common theme of physical, real-world things. The idea is to provide students with a comprehensive understanding of what Internet of Things is. I think most of you know of IoT. You've heard of IoT so many times. So we're going to delve a little bit into IoT. Unfortunately, you have not taken a course in embedded system. I heard the computer science people are taking that course. That is fine. There'll be a bit of embedded system also relating to IoT in here. The primary objective for this particular course is to, help you have some sort of understanding when it comes to things relating to the internet and web technologies that relates so much to the Internet of Things. So you have a general idea of what IoT is. Now, most times, anytime we lecture, these few things, we all most of the time talk about it. Now, on the VLE, I have all these lectures outlined. We would have about 5, maximum 6 lectures in this course. And there is a practical section. I have a TA who will be helping out. I will talk to you about him. So first of all, in lecture 1, today, I'm going to introduce to you what IoT is. Lecture 2, we will talk about the architecture and domains that relates to IoT. The devices itself, IoT platforms that exist, we will talk about them, communication and IoT plus Arduino. So we have a practical section by using components, using Arduino to build, IoT related stuff. Now, the course presentation, these things you already know, but most times, virtually every lecturer keeps talking about it, mainly because, we want you to be abreast of what will really happen in the course of the semester. So there will be lectures, there will be tutorials, and there will be practical section. And all materials that I'm going to give you would be on the VLE. Now, on the timetable, you already know that we're supposed to have met yesterday, 9 to 11. I think it was supposed to be in the classroom. The classroom, I'll meet you in class, all right, but I personally would want to use the classroom for the practical aspect. I think today, ideally, we're supposed to meet in LH1, which is over here. Because we're beginning with the course, that's how come we are doing it on VLE. So on the Tuesdays, I will hold a lecture online on VLE with you guys. Then on the Wednesdays, I'll be in class with you. But we are not starting the practicals now, possibly in the next 2 weeks. Depending on how things go. If we have to start from next week, I'll let you know about it. All right, so these things are just things that you already know. So let me just move on to this. So attendance, you know all these, we might have group presentation. All these things are tentative. The final thing, as and when things, go in the semester, There might be some modification in here. But of course, I'm going to give you will have some quizzes. Of course, you will not, you will have some quizzes in there, and you'll have some practical session too as well. Exams, it's also going to be tentative. I don't know whether I will give you a theoretical exam or an MCQ exam or a practical exam. I will tell you in the course of the semester. These policies, you also have what they are. I've been with you for a while, so at least you have not to cheat, things that relates to policies. Make sure you stick to it. Now, anytime I give you an assignment, make sure you don't copy from your friend. Now, as of now, I already loaded an assignment online for you guys to take after chapter lecture 1. So please make sure you hit on it. It's on the video, but I will show you on the slides too as well. Now we will have some for the practical section. There will be software and hardware related stuff that we'll talk about. In terms of the hardware, we have some microcontrollers in there. These are the hardwares that we're going to possibly use to build some applications that relates to IoT stuff. Most of them, we might not have everything in the lab, but the ones that we have will make good use of them and build some applications. So some hardware application. This will be the software that will possibly the Arduino IDE itself and so on. So you have some first-hand knowledge in how to, how some of these software are able to talk to the hardware in terms of building IoT stuff. Now let's begin the lecture itself. I'm going to begin with the introduction to IoT. And since you told me you had an idea, Nanakum, can you tell me what you think IoTs are? Like your general idea. I just want to know how you understand IoT. Don't give me a definition from Google. Just speak to me how you understand IoTs are. What do you think it is? Yeah.
Hello.
Yes, we can hear you. Solomon Blay.
All right.
Everything okay?
Hello.
Yes. Yeah, can we hear you?
Yeah. All right. So when we talk about IoT, all I understand is interconnectivity between devices to send messages.
Your voice is far away, and we keep getting echoes. So can we have another person? Justice. Your sound is Justice. When we say IoT, how do you understand it? I agree, Justice. Daniela, get ready. Yes, Justice?
Oh.
Yes, hello, Justice. Yes, I can hear you. Hey, do I now start deducting marks? Daniela, let's hear you.
Sir.
Our Evo classroom, yes.
Hello, sir. Sir, please. I know that is the network of devices.
A network, that's all you can say? Yes, Emisa Bwedi. Yeah, Bwedi, Emisa. Yes, let's have you.
So I think in terms of things, basically the devices that can have access to the internet.
Ideally, yes, you're right. That is a very good basic understanding of what it is. Yeah. Thank you very much, Samuel. Yeah, so we begin with lecture 1, which is Internet of Things. Now, most of you have heard Internet of Things, and at least you have, as the name says, Internet of Things. So Internet of Things, things that have access to the internet. Well, in this particular course, I would try my best to provide you with the basic and also the advanced concept of Internet of Things, which we normally term as IoT. Well, mainly the course have been designed in such a way that if you're a beginner and you're a professional, you have some knowledge that relates to this IoT stuff. So IoT in itself, by definition, as you can see, is an abbreviation that stands for Internet of Things. And what it does is it refers to accessing and controlling daily usable equipment and devices using the internet. So there are some keywords that I would want you to have in mind. When you hear of, for instance, in a quiz or an exam, when I say what is IoT, first of all, you should let me know that it stands for Internet of Things. And you should also let me know that it refers to accessing and also controlling daily usable equipment. And these devices, are possible because they have access connected to the internet. So that is what, in general, we can say an IoT. Well, this particular course, what we're going to do is I'm going to include most of the topics that I showed you earlier on. So I would, of course, I'm beginning with the introduction. I will delve into, that is for the introduction itself in today's lecture. These are some of the topics that I'm going to consider. I'm going to start with the introduction, which is happening right now. Then I'll build on it to give you the features, the advantages and disadvantages of IoTs, and how the IoT ecosystem actually really looks like. I will delve into the decision framework of IoT, the architecture, and also the domain, some door systems, and so on. Virtually every device, all the applications that relates to IoT, I'm going to talk about them today. So you can see for today's, these are the outlines that I'm going to hit on. I've already started with the introduction. So in general, when you hear of what IoT is, there are some things that you should always have in mind. So let's closely examine a typical example, like our mobile phones. Most of the mobile phones that we have, they have the onboards. Actually, the mobile phones that we have, I'm not talking about the Symbian phones or the Nokia 3310, those that are not connected to the internet. First of all, the device needs to have access to the internet. So most of these mobile phones that we have, if we examine it closely, we'll realize that it has a GPS tracking system in there. It has some sort of adaptive voice detection, face detection, and so on. It has all these things. So most all these components have their individual features. For instance, GPS help us to know the location, the brightness itself, the voice detection. There are specific things that they do. So all of these components have their individual. But if we put all of them together, they might be able to communicate with each other to provide some sort of better experience for us. So, and if we take up an example like the brightness, it could be adjusted based on your GPS location. Or right now, when you do swipe down your phone, there's a possibility to increase the brightness, but there's a where you have most times an A, which stands for automatic adjust, especially with the Android phones. So in such situations, if you are in a dark room, the brightness of the phone is reduced to a barest minimum, making it possible to see what is actually happening. The moment you come out from the dark room to maybe a sunny place, automatically the automatic adjust, now increases the brightness because you are in a brighter environment. So it increases the brightness for you to see, your screen or the things that are on your phone. I'm sure most of you have had first-hand knowledge or some kind of experience with this particular thing that I'm talking about. So based on the brightness, so it means your phone would have a sensor to get some sort of data. The sensor will get some data from maybe illumination data from your surroundings, and based on how dark or bright the illumination is, it's now the sensor now automatically adjusts to adjust the brightness of your phone so that you see, things clearly on your phone. So that is one example, So whenever we connect everything, especially the embedded, we normally embed with the electronics, the software, the sensors to the internet. It enables most of these things to collect and also exchange data without human interaction, just like how I talked to you about. The moment you came out, because it was on auto adjust, it automatically collected that data to know that indeed you are in a brighter environment. So there's a high probability you might not see your screen. So let me just increase it. So this whole thing is centered on what we call Internet of Things. So connecting everyday things with electronics, software, and sensors to the internet enable them to collect and exchange data without human interaction. And we normally term this as Internet Things, which is IoT. I keep giving different examples and scenarios just to have, so that you have some broader knowledge of this. Now, when you hear the term in the Internet of Things, it refers to anything and everything in day-to-day life that is accessed or connected through the internet. So the things in the Internet of Things refers to anything. So it has to be anything. When you say anything, it has to be something that is electronic, not your table or whatever. So if it is electronic, it means it has access to the internet. So the things that we talk about in here in the Internet of Things refers to anything and everything in our day-to-day life that is accessed or connected through the internet. So if you have anything that is not electronic, or that doesn't have access to the internet, then you can't classify them to fall under Internet of Things. Now, on your screen is you can see a diagram of some of the devices or the things that we keep talking about that have access to the internet, that can have access to the internet. So we have the wearable device, smartphones, vehicles, home lighting, home appliance, music, personal computer analytics. All these things are things that can be linked together to get access onto the internet. So of course, these devices come together because they get themselves connected onto the internet. We will classify them as things of the internet. I hope I'm right. Things of the internet, Internet of Things. Yes, I think there is a chat. Let me see if yes, indeed. Yeah, Edson. Hey, Edson. Yeah. Make sure you see me when you have time, right? All right. So IoT is an advanced automation and analytics system that incorporates artificial intelligence, sensors, networking, electronics, cloud messages, all these things coming together to deliver some sort of comprehensive system for products or services. So the system created by IoT itself refers greater to transparency, and some sort of control and also performance. When you have all these things and you're able to send information and put things together, things become so easy for us. Let me try and see, let me try and give an example. We have platforms such as the cloud that contains all the data through which we connect all the things around us. So if we have a cloud, you see over here, this cloud is responsible for containing all the data through which the information we get from the sensors and all of that, or things that relate to the internet, gets stored over here. So all these are connected. All these things that are around us, they all get all their data are connected in the cloud over here. So let's take an example. Assuming we are in a house, we can connect our home appliances such as the air condition, the lights, the light that we see, or virtually microwave, anything that's our TVs that we has access to the internet. We can connect all of them together. And once we're able to do that, we'll be able to manage all these things on the same platform. So we can also connect our car, our trucks, which has fuel in them, to see our fuel level, to see the speed at which we are running, the location of our car, and so on and so forth. Some cars, they have this GPS in them. So when it gets stolen, because the GPS is hidden somewhere in the car, they are able to, trace and locate the GPS itself. Please let me pick this call. I'm going to mute this myself for a second. All right, thank you, and sorry about that. I had to pick the call. Yes, so we have our clouds, all the data that is being gathered from all these devices that are connected online can be stored, and we can analyze said data and so on and so forth. So if there is a common platform where all these things can get themselves connected with each other, it will be very great. Well, this is based on my preference itself. I can set, so for instance, I can set the room temperature at any point in time. So if I prefer the room temperature to be set to maybe 16 degrees Celsius, in fact, there are times when maybe I don't come to the office early. I come possibly 12 o'clock and I'm feeling so hot. If, for instance, the air conditioning in my office, is connected onto the internet and I'm linked to it in one way or the other, and I have a smartwatch on my wrist and it's connected to my phone, and the moment I get to possibly maybe about 5 minutes out to my office, because my location is possibly being shared, stored somewhere in the cloud, my GPS location has been shared somewhere on the cloud. The air condition is also talking to that data which is shared on the cloud. Internet of Things, these devices try to, they get themselves connected to pull data from one point to the other and also make things analyze and make things work. So in that case, if about 5 minutes out to the office, the air condition, based on my location, the air condition can kick in. So by the time I get to the office, the place is already, chilled, and I can have a very cool air, passing over me. That is an example of how Internet of Things can be put together, for comfort and all of that. So in such a situation, that is very possible. So there are other things that can also happen. So for instance, in terms of voice, maybe in my house, maybe there's a garage, and I'm about a minute away from the house. The garage is connected to maybe the pullings, or maybe the machine that opens the door of the garage, is connected to the internet. Based on my location, which is about a minute or 30 seconds out, that data is sent to the cloud. The garage It's connected to the internet, which is also in the cloud. So it's able to pull that data. It knows where I am at that particular point in time. Then it opens the gate for me or the garage for me. I just drive in. So with Internet of Things, all these things are possible. And that is what I want to put across. All right, so how does it actually work? You know, we've been talking about Internet of Things, Internet. How does it really work? Usually the working of IoTs, they vary across different ecosystems in terms of architecture, IoT ecosystem in terms of architecture. However, there is this, the key concepts, you know, remain the same. They are similar throughout for all type of IoT devices in terms of how it works. So the entire IoT or Internet of Things process starts with the device themselves. You know, the device that is getting access, getting connected onto the internet. And said devices could be your smart watch, your smartphone, your electronic appliances like your TV. So all these devices actually start with the device themselves. And in this case, it securely communicates with the IoT platform itself. So the IoT device itself is the starting point of the IoT process. And they have to find a way to securely, you know, communicate their data to the IoT platform itself. So that is how, so the platform, what it does is it collects the data that is coming from your smartphone, your smartwatch, your electronic devices, and all these devices that are connected to the internet. It collects all these data. It analyzes the data from multiple of these devices and also transfer the most valuable data to their application on these devices itself. So that basically is how the IoT works. Now, when you look at, there are others, you know, these are other variations of how IoT also works. Those of you who want to read a step further and go on how it works. But the primary thing is, you know, most of the things that goes in there would always have to start with the device itself. And the device themselves finding ways to securely communicate to the platform itself, sending the data and all of that. And once the data is on the platform, this data now have to be, you know, collected and analyzed in a way that will be transferred, and the most valuable data will be sent to the application on these devices that try to talk to the cloud. Now, yes, so these are other variations or variants of the explanation of how IoT also works. One school of thought also believe that the IoT device gather data and send it through the internet for processing. You know, so step one itself, these are the IoT devices. They gather information, in this case, data, because it's on process information. They gather data and send it through the internet for processing. So this is step one. Through these are the devices. The data is being gathered on the devices based on the type of sensors or what the devices are meant to do. And through the internet, they are able to send the data to the cloud for processing. So in this case, the cloud is a data center, which is possibly located somewhere. So step one, send through the internet to step two. Now at this data center, data is analyzed centrally. And for if it's a sensor data, it is analyzed. Then finally, we come to step three. It passes through the internet. Also, the instruction based on the analysis are returned to the device again through the internet. So it does the analysis. The analogy I gave, I'm 10 minutes away. So it means my location is sent through the internet from my car or my phone through the internet to the data center. Analysis is being made. It is then pushed. Maybe it has been programmed that air conditioning should be on whenever there is 5 minutes away. So that processing happens at the data center, and that information is now triggered to send back again to my IoT device. The IoT device, which is this time around not my phone, but my air condition to take over. So instructions based on the analysis are returned to the devices. So that is how IoT also works. So it's just about the same explanation that I gave in here. So generally, they all go through the same architecture design. They are similar in most ways. So, and this is another school of thought of how IoTs work. So we can have the IoTs, all those devices coming here. Now, this is step one, data injection. Of course, we need IoT devices collect data from the environment and so forth. You can read these ones, most of these are self-explanatory. I'm sure most of you understand what I'm trying to say. Now, with all these sets, there are certain key things that relates to IoT in terms of features. Now, the most important feature of IoT, which most of the time form the foundation of IoT features, relates to connectivity, analysis or analyzing, integrating, activity management, sensing, activity, endpoint management, and so on and so forth. So I'm going to hit on each one of them. Let's take the first feature of IoT, which is connectivity. Now, in terms of connectivity, what is very important is the establishment of a proper connection between all the IoT devices and the IoT platform. That is what is on the cloud or the data center, which is this one. So it is important in terms of connectivity, there's a necessity to establish a proper connection between all the IoT devices, IoT platform, which is also located on the cloud. Now, it requires high-speed messaging between devices in the cloud to enable reliable, secure, and bidirectional communication. And when you say bidirectional, that is moving from a different direction, in and out, So in terms of connectivity, it is very important. So there are some houses that you have maybe these cameras, and the cameras are connected to routers in the house and the routers are also connected to the internet. So I can be in my office. If my son is in the house, and I have a babysitter, most of you have seen all these things. I can sit in the comfort of my office, launch the application that is responsible for picking data from the sensor, which is the camera in my house, and also view everything that is happening. So I might be here and I would know my, what do you call it? My nanny doing to my kid. There has been issues and situations where, things do happen. So these are things that go in there. But I mean, in terms of the feature of connectivity, if there is a glitch or there is power outage, the router goes off, it means I will not be able to access what is happening at home. So connectivity is one key feature whenever you hear IoT. Now, in terms of the analyzing, it involves real-time analysis of the data collected to build effective business intelligence. To build effective business intelligence. What I'm looking out for from my camera is continuous viewing of what is happening in my house. So my business, in this case, or the kind of data that I'm looking out for, is a continuous streaming of what happens in my house. Yes, Samuel, you have your hands up. Yes.
Yes, sir. I was asking if the devices in question require constant internet connection.
Yes.
Expansion.
Yes. Yeah, that is true. The IoT devices, as the name says, Internet of Things. So things have to be on the internet. So if you are not on the internet, then it forfeits the reason for being an IoT device. So, and the reason is per the architecture I showed you, for IoT to work properly, these key things need to happen. We should have internet. We should have those devices. and we should have a data center or a cloud that will pick up those information and give us returns based on the analysis that it does. So if you don't have internet access, then it means the device is IoT itself, but at that particular time, it forfeits the purpose of being an IoT. But that does not mean that, like the camera example as I gave, that does not mean that the camera is not an IoT device. Once it has access to the internet, even if the internet goes off, it's still an IoT device. But for it to be functional, these key things needs to be available. The IoT devices itself, the internet should be there, and also the corporate data center or the cloud services should also be there. That forms the architecture or the basis for IoT to actually work. All right, Samuel. All right, so I think we can move on. So in terms of the connectivity, that is the explanation that I gave in there. So of course, we are in Africa, and then the internet can go off at any point in time. So, but that does not mean that the device is not IoT. The device, once it has a network card or a network interface card to get access to the internet, it becomes an IoT device. Yeah. Sorry. Yes, let's talk about the second one, which is the analyzing. So in terms of that feature, it involves real-time analysis of data collected to build effective business intelligence. That is what I talked about. What I am looking out for is data should be sent to a data center for me to in real time see what is happening in my house, or in real time, based on my location, activate the air conditioning in my office to come on. Or an example can also be that, for instance, if I'm walking to my car, and my car has an IoT, technology in there. Once I'm about, let's say, about a minute away from the car can start and wait for me, put on the air conditioner or roll down the glass for all the hot air to, come out. These are all data that can be collected and analyzed and used to do other things. So these are all possible. So if we gain good insights from the data which we gather, we can call all systems as systems. So that is how come we have smart homes and all of that. So the moment we are able to gain good insights from the data that is being gathered at the data center or the cloud, we can confidently say that our systems are, all these systems can be classified as smart systems. They are smart enough to know what to do at any point in time, based on your preference. In terms of the feature, which is the integrating, it integrates various models to improve the user experience. As you can see, we can have so many things coming in. So there are different models that can help improve the experience, of the user. I'm the one using it. So I can do it. I can make sure some sort of configuration with other IoT devices to perform certain things for me. So an example can also be, so for instance, we can have an IoT. Dr. Ifa in the department, for instance, has been working around agri IoT. And in that case, he's able to place some sensors in the soil. So the moment the moisture content in the soil drops to a threshold, the data is sent Bluetooth. I think he uses Bluetooth, via Bluetooth to the inbuilt data center. I think he has a GSM model, so it could go. Data is sent to his data center. That is where the collection of information from IoT devices are stored. Analysis is performed on that data, and in that case, the sensor now sends that the moisture content has reduced to this threshold. It is done online, computation is done, analysis is made, then automatically, maybe the pipe is open for water to flow on the soil. So these are things that can really happen. We can configure and do so many things as whatever we want to improve the user experience with these IoT devices. You can also see AI over here. Now, AI is virtually everywhere. you and I can bear with me. AI has come to stay. We will learn from it. I'm sure most of you have not really paid attention to this. Please, ChatGPT can now talk. I'm sure you might have, and you might probably not, have activated that option on your Android phone and your iPhones. You can download the ChatGPT itself, use your Google account to access it. And there is a portion at the settings. You can go there and activate it. And if you want to learn more things about, you can talk to it.
Recording in progress.
New baby.
And that's what we're free for now. On another person, the whole cancer uncle for no. Uncle for no worry medical.
Hey, she just entered and she's talking. Please, if you want to talk, just raise your hand. I'll give you access to talk. So I have everybody muted now. So now, so most of you, those of you who have not activated that, you can now talk to ChatGPT and have very good interaction with ChatGPT. Go in there and do those settings. Let's just use a minute to tap some small information in here. Just a minute, please. I like technology, so I will always want to learn. It's not like I have most students around me, so they tell me things and I learn from it. Okay, so just a minute. All right, so our advice, you get that activated. That is the GPT Plus. I think that is on 4.4.4 or so. You can get that one activated and, learn from it. Use it to learn. I use it a lot. I learn from it, You talk to it. You can ask it questions about IoT. It will give you examples, so many things that you can, All right, so that was just by the way, in way of information. Let's move on. So in artificial intelligence, as I talked about. So in this case, because of AI, we are able to make devices smart and also enhance our life through the data that is being gathered. ChatGPT, for instance, is built on tons and tons of data and records, being video and all of that has been put online for us to use. So it makes things so easy for us. So we can have an example as stated in there. We can have a coffee machine that orders coffee beans automatically when the supply is low. So the moment we have a coffee machine, the moment the coffee goes low, it does an order automatically, and the supplier now comes in there to replace, replenish the, the beans that is in the coffee machine. Like the ATMs that we have in here, the ATM machines can be integrated in such a way that the moment an amount, is reached, a text message is probably sent to the supplier, to come and do something. You realize that possibly in the practical session, you can be here and maybe if your light is off, You can just send a text message to the GSM controller, using the GSM controller to your IoT device in a way, and it talks to it, and you can put your lights on. You can do other things. Mind you, artificial intelligence is there to make most of these devices smart. You know, it helps enhance all these features. Now, in the area of sensing as a feature, let me go. Sensing. So we have sensor devices in IoT being able to detect and also measure environmental changes and report their status. So there are certain sensors, for instance, if the atmosphere darkens, then your light is on. So these are all sensing features that relates to IoT. We're able to transform passive network into active network. You know, without sensors, an active IoT environment is not possible. So with this explanation, passive, we're able to transform passive network into active network. So for instance, if something is passive, then it is quiet on the low. So the moment something happens, the sensor triggers an action, and that action makes the network active. And in that case, you know, things can happen. You know, there's a possibility of the IoT doing or performing some particular type of activity or action. So this is also a feature. We have active engagements, and in this case, it enables active engagement between the connected technologies, products, and also services. And finally, when we talk of the endpoints management, it's essential for the management of all the IoT devices or systems endpoints, and it's find a way to avoid system failure. You know, it's essential for the management of all these IoT system endpoints. And this helps in avoiding system failure. I gave an example of what machine can do, you know, by ordering beans while you are away can lead to failure without proper endpoint management. So if you don't have a very good endpoint management, your coffee machine ordering beans in your absence will fail if we don't have any proper endpoint management system to be doing all this. So talking about the advantages of IoTs, just like any technology that is available today, we don't have any technology that is 100% that has the capability of performing virtually all the tasks. Smart bracelets doesn't actually require internet connection, but records health information such as blood pressure, body temperature, and so on and so forth, Bluetooth and all that. Can I infer these smart and perhaps bracelets as IoT devices? We should Bluetooth as. All right, so the example that we give, that is Clovet upon. Yeah, of course, most of the smart devices, they get connected onto the phone. But the ones that are not connected to the phone, they can still measure blood pressure and so on and so forth. In this case, you know, for a device to be an IoT, there is this key thing that you shouldn't forget. It has to be able to connect onto the internet. And in connecting to it, per the architecture that I showed you, we should have a data center or a cloud to store such data. So if I have a smartphone, a smartwatch that does not connect to the internet, of course, it's able to gather my health, my blood pressure, and also heartbeat and all of that, because it is manually connected to this, maybe my wrist, to do these computation. But where does the data go? The data does not go anywhere. But the moment the smartphone, or the smartwatch is connected Bluetoothly to my smartphone, it's connected onto the internet, then the data can now be transferred via Bluetooth to the cloud service. I don't know if Clovet understand what I'm trying to say. So until there is a way to get it connected onto the internet, we can't really classify it as an IoT device. But most of the smartphones or smart bracelets or smartwatches that we do have, they are linked Bluetoothly to the smart phones that has access to the internet. That is how come most times we say maybe most of the smart bracelets are IoT devices. And of course, there are other smart devices have access to the direct access to the internet. So those ones automatically are smart devices. But if you get what I'm trying to say, just let me know. No, that's okay. That's fine. All right. So these devices should be able to have access to the internet. If it doesn't have, it should be able to have access. If not, there should be a way to connect to a device that has access to the internet. And in putting these two together, we can classify them as a smart device, IoT devices. But most times, Bluetooth is also a form of connectivity, which you can use to send information or data to the cloud services that you have. If you have one setup in a way, you can do all these things in there. All right, so in terms of the advantage, as I said, any technology that is available today has not reached its 100% capability, and there is always room for improvement. And because of that, we can say that IoT is some sort of significant technology that we can help other technologies reach its full potential. Now, I want us to take a look at the major advantages and also the disadvantages of IoTs. Let's first of all talk about the advantages. As you can see, I said major. There are so many advantages, but the key ones are the ones that have been highlighted on your screen. Now, the Internet of Things offers several advantages in our day-to-day activities, and some of its benefits are the ones that you see over here. In terms of we have efficient resource utilization by understanding how each device works, and will, in a way, enable us to increase efficient resource utilization and also better monitoring of natural resources. Let me use this as an example. If maybe I'm traveling for a weekend, and my house is there, I don't want people to know that I'm not around. What I can do is, of course, when it is evening, my light has to be on. I can have some sort of a sensor. I can have a sensor to be able to put on the light for me in my absence. The moment the clouds get darkened, sensor picks it, possibly loads it online, and based on the application that I have possibly on my phone, it does. The light will come on maybe after 6 when it is getting darkened. So in this case, I don't need to put on my lights for the 72 hours that I'm not in the house. I went for a weekend, so the light doesn't need to be on throughout. But because I have a sensor or I have an IoT device that's connected online that does some of these things on my behalf, I'm able to efficiently manage resources. So in this case, I've increased efficient resource utilization. And by so doing, I have a better monitoring of resources and natural resources. I don't need to waste my lights doesn't have to be on throughout to increase my electricity bill and so on and so forth. So with IoTs, we are able to efficiently manage resources. Again, we have minimized human efforts. I don't need to, keep putting my lights on in my absence. Maybe I'm not there. Maybe 6 o'clock, that automatically will go on my phone and activate the light for it to come on. I don't need to do that. IoT with a feature of artificial intelligence, I can now program it in such a way that all these things will be done without my human intervention. So there is a minimum or minimized human efforts coming in. So IoT devices interact and communicate with each other to perform many tasks, reducing human efforts. We have saved time. With the same example I have given, you can see that the advantages keep trickling. By reducing human efforts, IoT will help save time. Time is a primary factor that can be saved through IoT platforms. We normally say time is money. I don't need to waste time to do other things. If I have I'm doing things that can get me money, I don't need to waste any other time. So the introduction of IoT in most of these technologies help save time. Enhance data collection. And with this, we are able to improve data collection capability by providing valuable insights and also informed decision making. And finally, we have the improved security. The interconnected systems that we have makes it possible to enhance security and also efficiently and also enhance some sort of the security efficiency by monitoring and managing connected devices. There are some key things that we always have to have in mind, and that falls under the disadvantage, IoTs in itself, when the manufacturers are, building these IoTs, their concern is, excuse me, their concern is making the device work. So they don't really care about the security of, most times, they don't really care about the security of the security that goes in there. So that falls under the disadvantage. I'll give an explanation to that. So whilst the IoT offers many benefits, it also presents significant challenges, and some of these have security, privacy, and complexity. Most of the IoT systems are, because they are interconnected and communicate over the network, if we don't offer little control in terms of security measures, there's a high probability that our information or data will be leaked and sent to the wrong person. So this can lead to various kinds of network attacks. And an example, the reason I was saying all this was because I said most of these manufacturers that build these devices, let's use the camera for instance. The camera has access to the internet now, it can go online. The camera in itself is unable to work from your introduction to computing or computing technology. You know very well that, like your phone, the hardware itself doesn't do anything. It's something we call a software. So in the case of the phone, we normally term it as a firmware. Now, if it is a firmware, that means our firmware needs to be in such a way that the firmware are the ones that are able to talk to our hardware. Now, these manufacturers, when they produce the firmware for these IoT devices, most of the time, they don't bring out patches when there are vulnerabilities in those software. So for instance, the camera, for instance, there's a firmware that is making it possible for the camera to function, the hardware camera itself to function. Once the firmware is installed, hardly as the firmware, gets updated. Most of the manufacturers don't update it, So, and that the way technology is, that is, if firmwares or software or any application doesn't take an update, high probability that there will be a vulnerability in the firmware or the software, and network attacks or hackers can also route through those vulnerabilities and also affects our devices. So these are key things that we should have to be mindful of. In terms of privacy, even without active user participation, IoT systems can provide substantial personal data in maximum details, raising privacy concerns. If you get yourself connected to a platform that is able to store your daily works, your heartbeats, you are gathering all these data and it's being stored in a data center. Then once someone gets access to your data, they get to know of the ability. Maybe you have a high blood pressure, or you have issues with this. You're not supposed to issue that. Like, if somebody wants to really deal with you, they can have ways to, because of this privacy, because of these data being stored on the data centers. If it's not being secured properly, there's a privacy concern that comes in there. So these are few things that raises an alarm when it comes to IoT stuff. And finally, complexity. And this relates to designing, developing, and maintaining, and also enabling large-scale IoT systems. Most times it's quite complicated, It's most IoT products, they are quite complicated when it comes to designing and also development, maintenance, and so on and so forth. So those are the advantages and disadvantages of IoTs. Embedded systems in IoT. We'll finish very soon. Let me see how many. Yeah, so embedded systems or devices in IoT. Usually embedded systems and IoTs normally work hand in hand, So understanding embedded systems, embedded devices itself is of the time very crucial when we're learning about IoTs, or we are actually building projects in IoT. Most times, embedded devices are objects that form unique computing systems. And these systems, most of the time, are not connected to the internet. So the embedded systems that we have, in fact, when we have embedded systems usually they are standalone devices. They are not connected onto the internet. The moment we introduce the internet to it, or the moment embedded systems get access to the internet, then it now relates to a device that we term as Internet of Things. It's an IoT device. I think you get it. So an embedded device system generally runs on a single application. It has nowhere to go. However, these devices can connect through the internet and also communicate with. The moment they get access to the internet, we can say embedded systems are now IoTs. But ideally, most embedded systems, they are standalone devices. They run some single application, like the smartwatch, as our gentleman said. If it doesn't have any Bluetooth connection to get access to a device that gets onto the internet, and it is mainly for measuring your heartbeat and pulses and so on, and it doesn't transfer data to anywhere, it means it has just a single application and it becomes an embedded system. Once it gets itself connected onto the internet to send data and all these things, becomes an IoT. All right. So usually embedded systems, IoTs, they relate and go hand in hand. Now, this is the diagram of what is being shown here. So it's most of the time important to know about the system itself while learning IoTs, as I said. The embedded system are the objects that build the unique computing system, and these systems may not connect onto the internet, as I said. So an embedded system generally runs single application, embedded devices in Internet of Things. So once they have access to the internet, we want to most of the time classify them as IoTs. So you can see an embedded system over here. It has a Wi-Fi, Bluetooth, Ethernet, Zigbee, ISDL, Internet version 4 or 6, depending on the type. They have these peripheral sensors, actuators, drives. Most of these hardware stuff will be dealing with them in class on a practical basis. And these are the local networks. These are local networks. We can have a local area network, wide area network, MANET, and so on and so forth. So that is the embedded system. Once it goes onto the internet, then it's more or less becoming an Internet of Things. So there are types of embedded systems. So on your screen here, the embedded system can be of two main types it can be of type or type of microprocessor. So both of these could be a microcontroller or a microprocessor. So there are two main types that exist when we talk about the embedded systems that relates to that. So both of these devices can contain an integrated circuit. Say integrated circuit. You know, most of these electronic people say IC, IC. Your IC is dead. Your IC is dead. You need to replace an IC and so on. So those are integrated circuits. So the essential components of an embedded system most of the time falls within the RICS, where we have the microcontroller like the Motorola 68HC11, the PIC, and so on and so forth. Some of these, we have some of these hardware in the lab. Yes, my TA is coming, so I've told him to start preparing for the practical, so he will also be helping out in the practical aspects of this course. Yeah, so the most important factor that differentiates these microcontrollers with the microprocessors, you know, like the 8085, is their internal read and write memories. And those of you who have not seen a microcontroller, there's an example. There's an Arduino microcontroller. Here's how a microcontroller looks like, you know, and this is the microprocessor. Your core i7, i5, i3, Pentium, Intel, all those things are microprocessors. CPU. So microprocessors. So these things you know. So the essential embedded devices, device components, and system architecture are what I'm going to show you here, as you can see. So there's the microcontroller. You know, these are the controllers. We have the actuators and all these. We can have some sort of notification connected to the microcontroller. There's the microcontroller. This one. Let me see if I can increase that. It's a little. So the way it is, sorry. The way it is, we can connect devices and things, pins and all of that. So that is a microcontroller. You can connect so many things, so many peripherals to it to perform certain tasks. We would have practical knowledge in that, yes. So that is a microcontroller, and these are controllers that we can, these are the controllers, all these things, notification, we can have a LED or a buzzer. In terms of the notification, we can have the LCD, you know, or LED displaying things for us, you know. Maybe if we have a sensor and the sensor notices the smell of gas, it will buzz. So you hear some buzzing sound, you know, that could form under, that could be an hardware that can help in terms of notification. Display units, we can have LCDs, we can have graphic displays, we can have all these displays. These are basic embedded systems. In terms of inputs, we can have switches, keypad, timer, and so on. In terms of sensor, these are examples of sensors that can get connected onto the microcontroller to perform certain tasks. So these are the ones that relate to it. So the microcontroller itself is more like the computer, and these are the peripherals that we can put in there to get some of these devices, you know, performing certain tasks and making it look more an IoT related stuff. All right, so the languages that we normally use for embedded system, let's talk about it. In terms of the software, what we talked about here is the hardware, and this is the software. So the hardware is what we have talked about. And of course, if you have the hardware, you need to have a software to be able to talk to the hardware. So the embedded system that uses the device for operating system is based on the language platform. Mainly where the real-time operation will be performed. And most times the manufacturers, they build embedded software in electronics. And the electronics could be in cars, telephones, modems, appliances, and so on. The embedded system software itself can be as simple as lighting controls running up to about 8-bit microcontroller. And it can also be, we can also have a complicated one in terms of the software. We can have a complicated software for missiles, process control systems, airplanes, and so on and so forth. Those falls under the application. So we have the language platform and also the application. And as I said, most of the manufacturers, when they have the hardware, they also would give you their software to that we can to talk and program the microprocessor to do these, any type of thing that we want it to do. Now, this is your first assignment, which is on a VLE. You are to write a 1-page document explaining how embedded systems and the Internet of Things are related. In your explanation, make sure you include the following points. You first of all can begin by defining what embedded system is or are, and their key components. You can define Internet of Things and its primary objectives. You can describe how embedded system contribute to the functionality of IoT devices, and you can provide examples of how embedded systems are utilized within IoT applications. These are the things that I expect you to, write your information about. Your explanation should be concise and focused, summarizing the relationship between two technologies in one paragraph. If it's 2 or 3 paragraphs, that's okay. But at least you should cover all these things that are in here. So that is assignment 1. And I'm going to use Turn It In. Please, you can gather resources for all these, but make sure you use your own English to write. And please, if you copy from your friend, I will know. You know me, Dada. You are my people, so you know. In terms of IoT, I have just some few slides. Let me just go through it. So the IoT ecosystem itself, we normally find it difficult to define it because it's quite complex. It is difficult to capture its proper image due to the vastness and also the emerging possibility and also the rapidity with which it expands in the entire sector. The ecosystem is quite broad. It's a little complex. But in spite of all these things, the IoT ecosystem itself is a connection of various kinds of devices that sense and analyze the data and communicates with each other over the network. So there are some key things that comes in here in terms of the concepts. So in IoT ecosystem itself, the user, most of the time, should always have that in mind, uses smart devices such as the watch, smartwatch, tablet, sensors, and so on and so forth. They use such devices to send the command or request which they are looking for to the device for information over the network. So without a network, all these things are not possible. The device itself responds by performing the command to send information back to the user through the networks after it has been optimized. So the architecture I showed you in previous times still goes in there. Things happen. So typically, IoT ecosystem is shown in the image that you see over here. So, and in this image, we have the smart devices. We have the smart devices send and receive data from devices themselves. And in so doing, the environments that are integrated over the network, and also the cloud computing itself. So these are the smart devices. So virtually everything, all these things, all these smart devices, they see data from the devices themselves in the environments that are integrated over the network and also the cloud computing. So the applications are the ones that we have in here, the software and the technologies that helps, to perform some of these tasks. Let me see. All right. Solomon was laughing some few minutes ago. All right. So the IoT decision framework itself, from what you see, what it does is it provides a structured approach to create powerful IoT products strategy. And in this case, the Internet of Things decision framework, which is the IoT framework, is all about strategy decision making. To understand the areas where we need to make decisions and also ensure that there's some sort of consistency across all the strategic businesses, and also the technical decisions that we make. Now, there are some key things. There's a key thing over here that I want you to pay attention to. And this is the IoT, in terms of the IoT decision framework. It is very important as the services that communicate over the internet goes through these 5 different layers of complexity of the technology itself. Of course, we have the hardware, the software, communication, cloud platform, cloud application. Each of them has been explained over here in terms of that's the physical components of the IoT itself. Those are the layers of complexity. In terms of the device software, that is the software that runs the IoT itself, the method for which the device is able to communicate with the other device on the network. That is where the communication comes in. The cloud platform, that is infrastructure for processing and storing data. That is where the data center is that contains the cloud services, or the service that's is able to store the data that we push out over there. And finally, we have the cloud application, that is software application that utilize the cloud data itself. So these are 5 different layers of complexity of technology that relates to the IoT decision framework. And of course, these are the ones that has been highlighted over here. The device hardware, software, communication, the cloud platform itself, and the application that runs on the cloud platform to provide and analyze our data and push it out to the IoT devices itself. So this is the IoT stack that exists. I'm almost done, so just bear with me. In terms of decision area, the IoT decision framework pays attention to 6 key decision areas in any IoT product. So these are the key areas that the IoT decision framework, pay attention to. So these decisions are what has been outlined in here. The first one, which is the user experience. Of course, second is the data, we have the business strategy, technology, security, standard, and also regulations. So each of these decision areas is evaluated at each of the IoT technology stack, which is what has been outlined over here. Each of these decision areas are evaluated at each of the IoT technology stack. And in this case, the user experience will be able to evaluate the device hardware, software, and also be able to provide better user experience. With all this in mind, the next step is to think about the data decision area. So in this case, we have to explore data consideration for all the stages of IoT technology stack, which is what we have over here. The technology stack that we have in here. So still on the decision. So I would want us to, take a look at each of the decision area of the IoT decision framework itself in details. So if we pick the first one, that is a UX, which is the user experience decision area. What it does is, this particular area is where we normally concentrate about who the user is, what are the requirements, and how to provide a great experience at each of the various steps of the IoT stack without worrying about the technical details. It says user experience decision. So it's meant, we normally think about the user. The concentration is about the user and what's the requirement is to make it easier for them to have a very good experience with the device that we have come out with. So this is still the technology stack itself, as you can see. Now, in terms of the business decision area, this is, the data decision area, which is the second one. In this area, we make sure that the overall data strategy, such as the data flow over the entire IoT stack, is fulfilled in the user, in terms of the user requirements, everything that the user needs to be abreast with, the data decision area is responsible for that. Business decision area is also based on this one. It's based on the decision area we make the decision, the product itself or the services with which we become, financially. We're talking about business, of course. If we are dealing with business, then we should be thinking about the financial potentials that exist in this particular area. When we are making such decisions, these things we need to, think about them. So at each of these IoT stack level, monetize about the cost of providing a service. So if what we're trying to do is quite expensive, we have to take a different route. We don't need to produce something that is quite expensive, than the amount we're going to make, at the end of the day. The next one is the technology decision area. Still all under decision area. In terms of technology, we normally work with the technology for each of the layer to facilitate the final solution. In terms of security, what we are looking out for is, after going through the implementation of the technology itself, it is always important to decide and also provide the security at each stage of the IoT stack. Security is very crucial in this particular area. We want to always make sure that any product that we put out there that is going to run our IoT device, is quite secure enough to prevent these adversaries from attacking us, stealing vital information from us. And finally, the standards and regulations, still under the decision area. This actually forms the last stage of the IoT decision area. And what we are concerned here is to identify the standard and the regulation of the products that we put out there. What that affects the livelihood of people, and will the products at each level, the standard that we put across there, we have to make sure that people are actually getting the best of things out of what we do produce. And this is very important, mainly because we think about the products or services that will affect your products and at each layer of the IoT. So we think about it and we make sure we come out with standards that would, make your users have a very good feel of the products that you have with. So generally, we've gone through the major things that relates to IoT. We've spoken about virtually all the things that I wanted to talk about over here in terms of the introduction, the features, the applications, the architecture, and the domains. These are things that we've actually talked about. So this brings us to the end of this particular lecture. And make sure, of course, we are not in class, but if not, I would have asked one individual to tell me. Is it too late to ask someone to tell us what he's learned? So people have started writing. All right, so please, that is about it. I would want you to take your time, go through the assignments, and make sure you do it. There's a deadline to it. That is exactly a week from now. So make sure you do the assignments. Does any of you have any question? Hello? Am I here alone?
Hello, sir. No, sir.
Okay. The place is quiet. Yes, because this is a new course, I will release the lecture materials as and when. So when we are done, I'll put everything together into a PDF for you as your lecture material. Yes, I want us to run very fast this semester. I'm hoping that about next week, somewhere in the middle of next month, I might be engaged for about 2 weeks in Accra. So I want us to run as fast as we can to touch on all the. I want us to run very fast so that I'll be able to touch on all the topics that I want to treat in IoT, especially the theory aspects, so that Kwamina can also help me with the practical aspects. So for instance, today I'm done with this. So the next time I meet you on VLE, this is what we're going to treat, the architecture and domains. So I'm sure we'll be able to finish before I leave. And when I come back, I think we will all be on the same page. Thank you very much for this. Let me stop this recording.